So here's the conclusion. Unfortunately, it didn't work on the LED light. It didn't work either on the incandescent light as well. So it does work for the motor, so I wanted to connect that and show you guys the end result of this. I attached a little piece of tape so you can see that we've created a little propeller here. So our battery is indeed working. So I'm going to put this over on the side because it's leaking all over the place. Can we get it to sit up? I don't know if we can get it to sit up or not. Here, maybe we'll do this. There we go. So that's something to watch while we do this lab. So what happens when you attach the battery to the light bulb? Well, we're going to say this isn't really the light bulb. This is actually going to be the motor. So we have the motor. Well, what's happening is the motor is moving. Why is the motor moving? Well, again, let's take a look at all the reactions that are taking place right here. Here is the magnesium. Again, this is the negative terminal of our battery or our voltaic cell. What happens is this is going to be losing the electrons. So it's going to be losing this is going to become dissolved magnesium, and the electrons will then flow out of the wire, and here are the two electrons that are going to be flowing out. It's then going to go through, well, instead of being our bulb, it's going to be the motor. The electrons will then flow in the other end, and this is going to be our copper. And inside here, this is our blue liquid. This is the blue copper sulfate, but it's really the copper ion that we're concerned with. So what happens is the electrons come in, and the blue liquid, which has the copper ion, starts to form these deposits on the surface of the copper. So here's my positive electrode over here. This is the source of the negative electrons. This is where the negative electrons are traveling towards. So here's my anode. Here is my cathode. So the motor is moving. Describe it fully. We have the flow of electrons through the motor. So here's part one. Part two, we have the flow of electrons through our device or through our motor. So describe the changes in the metal strips. You can't see it at this angle, but the metal plate, the zinc plate is bubbling. So the zinc plate, which is, no, actually not the zinc, it's the magnesium. The magnesium plate, the magnesium plate over here is bubbling. So if you turn to the last page, so I'm going to have to take out, I've just taken out the electrodes for us to see. And here's the copper. It's hard to see anything that's happened to the copper. It's a slight discoloration on the sides, but there have to be some deposits because our battery was running. But it's asking, what is the explanation for the coating right here on the magnesium strip? This is like what we just saw in a previous demonstration. What's causing this coating? Well, the dialysis tubing, let me go ahead and show you guys. the dialysis tubing is not a perfect plastic container. If I remove this blue sac, you can see that there's a slight bluish tinge on the inside of the water. So this is not a perfect setup because some of the copper actually leaks out of the baggie. So the copper, which is the blue, here's the blue copper, it leaks out of the tubing. It's the dialysis tubing, but we can just call it the tubing. And when it leaks out of the tubing, what happens is we have our zinc, or magnesium, our magnesium sitting there, and here comes along the copper ion, and those two will have a direct transfer of electrons. So what happens is the electrons transfer to the copper ion, and it forms solid copper, and it forms that on the magnesium strip, directly on the magnesium strip. So going back to the previous page, while we have the flow of electrons going around through the device, we also have some of this copper leaking out, okay, and we're going to have this direct transfer of the electrons also to the copper ion, and we're going to form the deposits over here as well. Now, do you expect the bulb or the motor to continue going on, moving forever? It was going for a significant period of time. Will it last forever? It's not. So I want you to think of one reason why it's not from lecture. What is happening to the anode, which is the magnesium? The magnesium was bubbling. The magnesium is actually dissolving. What's going to happen eventually to the magnesium? It's going to run out. Now on the other side, we have this blue copper ion. What's going to eventually happen to our copper ion? So the copper ion will eventually run out as well. So a battery won't last forever because our chemicals will eventually be used. In which direction do the electrons move in this reaction? It moves from the magnesium to the copper. So what can you say about magnesium compared to copper on the activity scale? Magnesium is going to be higher on the activity scale. Don't worry about doing number 4, and don't worry about doing number 5. That's it.